Okay. It is going to take a few seconds and we'll be able to start. Okay. Let's start. So yesterday we went through the introduction. So I presented yesterday the introduction, and we also started the first part of the course. Yes, we started this this other part of section of the course, that is theories of financial intermediation, and this is something that we're going to go through today. So we started with I presented this notion of symmetric information between two parties. I told you that actually there are three problems associated with symmetric information. The first one, which is called adverse selection, and second one, moral hazard, and finally a third one, which is called costly state verification. I also told you that along the lifetime of a financial contract, well, the three different problems associated with asymmetric information, let's say, are important but at different time. Adverse selection is crucial at the time of signature of the contract. Moral hazard is crucial during the lifetime of the project. That is, once the project is financed and before the end of the project, of course, because the behavior that you are going to take is going to affect the result of the project that you are running. And finally, the problem of costly state verification is going to occur at the time where there is the project's result. So we went through this first theory of diversification and delegated monitoring, and more precisely, I already talked about the two first points, if I remember well, point 1 and point 2. So the idea is really simple, is to say that if you delegate the control, the monitoring of the project to somebody else, you're going to save on monitoring costs. The idea is to avoid the duplication of monitoring costs. But of course, there is a new party which is involved in the relationships which is involved in the life of the project, that is the monitor, and which is going to be a financial intermediary, like for instance a bank. And in that case, well, the question is who monitors the monitor? Okay. And the third point, which we are going to go through today, is to show that diversification, and I'm going to explain what is the role of a bank in terms of diversification, reduces the information asymmetry between the delegated monitor and investors, and therefore reduces the cost of delegation. That is what we are going to start with today. Okay, so this is something we talked about yesterday. So if you compare, everybody is able to understand that NT is strictly lower than NMT, because of course M is strictly higher than 1. But you also have to take into account capital K, which corresponds to the cost of delegation. So the left hand side correspond to the entire cost of monitoring when using a financial intermediary. This is with a financial intermediary, while the right hand side is with direct banking, financing. Okay, so now I'm going to talk about how diversification reduces information asymmetries and then reduces the cost of delegation. Okay. So of course, if you have questions, do not hesitate to interrupt me or to type your question in the chat. And this is why time to time I'm going to go to this version rather than the full screen. Okay, is that clear so far? Is that clear so far? Just this recap. Okay, great. Okay, so what is the idea about diversification as a way to reduce information asymmetry and therefore to reduce the cost of delegation? Well, we consider that entrepreneurs actually, so let's say entrepreneurs are going to be the one which are going to look for financing. So they want to borrow money, right? So we consider that entrepreneurs are better informed about the quality of the project they wish to achieve than investors. So basically, there is a problem of adverse selection. So you remember when we talk about adverse selection, the question is, I don't know who you are. Who are you? I don't know who you are. Okay. But the investor, the entrepreneur knows perfectly who he is. That's the point. In this case, entrepreneurs, let's say of good quality, will want to signal themselves in order to obtain better financing conditions. Okay, so you have to remember that the question of adverse selection is always related to the question of signaling. Okay, this is the two sides of the same coin. But for doing this, they will choose to invest in a significant portion of their own wealth in the project they wish to achieve. This is going to be the signaling behavior of good, let's say, good entrepreneurs. Of course, this is costly for them because they don't like risk. They are what we call risk averse. Indeed, by investing personally in the project, they bear a significant part of the risk. In that case, and this is going to be the role associated with using a financial intermediary like a bank. In this case, we will see how a bank that group a number of entrepreneurs, borrowers, would actually reduce the cost of reporting. So basically, the first part is not related. I mean, all of this plus the first bullet point plus this is not related to the role of a financial intermediary. What is related to the role of a financial intermediary is the last bullet. So this is related to, this is the role of a financial intermediary, like for instance, a bank. Okay. So in other words, I mean, saying the same thing that this, but in other words, by regrouping within a bank entrepreneurs, borrowers, well, they will obtain better financing conditions than by seeking to borrow on their own. That the point which is important when you consider the introduction of a financial intermediary. And this is what we are going to develop now. So first of all, we have to understand what a capital market with adverse selection is. So let me consider the following simple model. So let's say that there are n entrepreneurs who each want to realize a project. So realizing the project necessitates an investment which is equal to capital I. and there are random return, and I don't know why you don't see R of theta. And this is net. This is not gross return. This is net return. Net return. Net return. Net of the investment. Okay? And we are talking about adverse selection because actually there are two types of project. So the two types of project are the two type creates wealth. The two types are profitable, but there is one type which is more profitable than the other. Okay, so there are two types of project. First of all, there is type 1 project, and this type of project is only weakly profitable. And there is type 2 project, and a type 2 project is more profitable. Okay, so what is theta 1? Well, actually, theta 1 is corresponds to the expected profitability of project theta 1. Okay, so this is, sorry, you remember this is net of the initial investment, and this is strictly positive. And theta 2 it corresponds what is different is that now it's no longer theta 1, but it is theta 2. And this is strictly higher than theta 1. So this is why we say that a type 2 project is more profitable than a type 1 project. So an entrepreneur, by definition, knows the type of the project that he's able to realize. But this is not the case of outside investors. So if you are an outside investor, you only know the ex-ante distribution between a type 1 project or a type 2 project. So let's say if you are an investor, you know that the probability of facing a type 1 project is equal to pi 1. So it also corresponds to the proportion in the economy of type 1's project. And for type 2 project, probability is equal to pi 2, which of course correspond to 1 minus pi 1. Okay. Okay. So this is why it corresponds to the average net return of a type 2 project. What else? Yes, we make the assumption, and we'll see why later on, that the net return of either a type 1 or type 2 project is distributed by a normal law. That is to say, this is distributed by a normal law. Okay, this follows a normal law with different expectation, but same variance. Same variance. Okay. Represent sign of expectation. E means expected. Okay. The expectation. Okay. Great. So what about this problem of adverse selection? Well, it is the fact that each entrepreneur knows the type of project he can realize rather than wants. He can realize, because it is not a choice. An entrepreneur doesn't have the choice between a type 1 or a type 2 project. Either the project he can run is a type 1, and in that case we're going to, in some extent, we can talk about type 1 entrepreneur, or it is just a type 2 project, and in that case we can talk about a type 2 entrepreneur, but it's not a choice. Okay, so each entrepreneur knows for sure the type of project he can realize, but not the capital market, not the financial market, that only knows the distribution a priori, that is to say what I detailed here. Only the proportion, let's say, of type 1 project and the proportion of type 2 project in the economy. This is the only information the financial market is aware of. So this is, let's say, a basic assumption. We are going to consider that the financial market is perfectly competitive and that investors are risk neutral, but entrepreneurs are risk averse. That is to say, investors are risk neutral, but this is not the case for the entrepreneur that actually are risk averse. So if they are risk averse, they should be characterized by what is called a utility function. And this is the kind of utility function that we are going to consider. Okay, this is called an exponential utility function. And you'll see that using an exponential utility function and the fact that here the risk, that is the random variables, are distributed by a normal law, this is going to simplify a lot how to resolve this problem. Okay, and there is an amount of collateral, so internal investment, if you prefer, that each entrepreneur has. Okay, and you see that first point to notice is that the level of collateral is strictly higher than what is required to realize the project. But investing in the project would imply to bear the risk. And any entrepreneur, since he's risk averse, he would prefer not to bear any risk. Okay, so what is the equilibrium in the capital market? Well, when I talk about the equilibrium in the capital market, what I want to find is the price that investors are ready to pay, or in other words, to invest in each firm, that is to pay to each entrepreneur. So what is a pooling equilibrium? A pooling equilibrium is a situation in which both type 1 and 2 entrepreneurs would accept to, in some extent, sell their firm to the financial market. So in that case, the price investors are ready to pay is correspond to the expected value of a firm. And the financial market know that with probability pi 1, the expected value is going to be associated with a type 1 firm, while with probability pi 2, and remember pi 2 is equal to 1 minus pi 1, is going to be pi 2. So the expected value is pi 1 times theta 1 plus pi 2 times theta 2. And of course, I'm sorry, but there are many things which are missing. I don't know why. I don't know why. Anyway, so you see that, of course, we have pi 1 theta 1 plus pi 2 theta 2, which is strictly higher than theta 1, but strictly lower than theta 2. So of course, if you are a type 1 entrepreneur, you accept this price. You say yes to that price for two reasons. First of all, because this price is strictly higher than the true value of your firm, the true expected value of your firm. And moreover, because by doing that, you get rid of the risk. So this is what you are really interested in. What about if you are a type 2 entrepreneur? Well, now things are a little bit more complicated. Why? Because if you accept this price, you get rid of the risk. So you obtain W0 plus P with probability 1. But you see that P is strictly lower than the true value of your firm, and you know that. The other possibility for you is to refuse this price and to go through the project. Okay, to go through the project. So now the question is to understand better in which situation the inequality is going to be in that direction. Because if the inequality is in that direction, well, we're going to have a pooling equilibrium. Because in that case, both type 1 and type 2 entrepreneurs are willing to accept this price, P, and therefore the true price is actually that one. Okay? So in order to be able to go a little bit further about how to say a little bit more about this inequality, we have to define what is called in financial economics certainty equivalent. I'm sorry, but I've got some problems with the slides. Let me check something. Yeah, there are many things which, okay, I see your point. But I would like to share something else. I don't understand why this is not working correctly. No. Let me check. Let me try something else. Sorry. Okay. Okay, so maybe it's going to be better. Okay. Yes, it's better. Okay. Yes, by the way, I've got a question about this. I mean, so this is the exponential function. Okay. It is 1 minus e of, this is the exponential of this value. Okay. This is the exponential function. I mean, the mathematical exponential function. Okay. Okay. So what is called the certainty equivalent? Well, this is a number, let's say. So small c belongs to R. And which is such that as an individual, I am indifferent between receiving C with probability equals to 1 or playing, let's say, a lottery. Okay? So I repeat, the certainty equivalent is the level of wealth that you can obtain for sure, which is such that an individual is just indifferent between this certain amount of wealth, C, and playing, let's say, to an uncertain lottery that is receiving R tilde. And the tilde means that there is uncertainty about the amount of wealth that you're going to receive in the future. So let me give you an example. Well, you see, consider a lottery which is going to give you 100 or 0 with probability 0.5. Oh, yeah. Okay. So Consider a lottery which is going to give you 100 with probability 0.5 or 0 with probability 0.5. Okay? So if you, this is, let's say, x tilde. So you can compute the expectation of x tilde, well, 50. But 50 is different from C. Because actually, if you are risk averse, you're going to modify this lottery and to find something like, for you, it is the utility associated to 100 and the utility associated with 0. And so for you, the expected utility is going to be this. And so the question is, what is C that you are going to receive with probability equal to 1? So C is such that E of U equal U of C. And there is no longer expectation, because you are going to receive C with probability equal to 1. If you are risk averse, what do you think about C compared to 50? What would be the inequality? What do you think about this? C compared to 50. What is your idea about that? Higher? No, actually, it is the contrary. Let me explain why. Well, 50 corresponds to the expected value of the lottery. But if you don't like risk, you can be a little bit, in order to be indifferent, C should be slightly lower than 50. Okay, let's say, of course, I always prefer 60 to, this is preferred to the lottery in which I'm going to have 100 or 0 with probability 1/2. Because 60 is for sure, and 60 is strictly higher than the expected value of the lottery. So for you, there is a trade-off. And this is why C, if you are risk averse, in our case, is strictly lower than 50. because you obtain less than the expected value of the lottery, but with certainty. And of course, the more you are risk averse, the lower is C compared to 50. Okay? Yes, less than 50. Less than 50, exactly. So I've got several questions. So expectation, yes, I explained already about that. We're going to have numerical examples later on. Okay, pooling equilibrium IC. IC also for canvas system. Okay, that is done. Okay, I see. Okay. Okay. So the utility is, so let me be a little bit more specific. The utility of wells is written like 1 minus exponential minus rho. So this is the wells, your wells. So for instance, if your wells is 10, then u of 10 is 1 minus exponential minus rho times 10. And this is a constant, so it belongs to R plus. And we'll see that actually it represents your risk aversion. The higher rho, the more you are risk averse. So in other words, Madam A is such that you and so in that case, 3, this is equivalent to say that Madam B is more risk averse than Madam A. Okay? Yes, about pooling equilibrium. So as an outside investor, you know that you don't know precisely the type of an entrepreneur, but you know the distribution between the two types of entrepreneur. So the price you want to pay is the average, the expected value. So it is pi 1 r tilde of theta 1 plus pi 1 implies 2, sorry, and r tilde of theta 2, which is pi 1 theta 1 plus pi 2 theta 2. But this value it is strictly higher than theta 1, so type 1 entrepreneur accept this price. But this is strictly lower than theta 2. So for a type 2 entrepreneur, there is a trade-off. Because on the one hand, if a type 2 entrepreneur accepts this price, well, he or she loses money. But on the other hand, he gets rid of the risk. And this is good because he or she is risk averse. Okay? No, P is a price. This is a price over there. It corresponds P. Here, P is not probability. It is a price. Price. This is a price. Well, this is the expected value, you know. If you know that the price is 50 or 10 with probability 1/2, 1/2, the average price, let's say the average value, the price corresponds to the average value. Okay, average value. Okay, corresponds to the average value, just the average value. Okay, so let me go back to this. Okay. Okay. So I told you that we were considering what is called an exponential utility function and a random variable distributed by a normal law. And in that case, actually, the certainty equivalent is very easy to write. It is very easy to write down the certainty equivalent. So basically, the certainty equivalent corresponds to the expected value of the random variable minus another term, which corresponds to a risk premium. This is a risk premium. Okay, And you see that when rho increases, the risk premium also increases which implies that C decreases. Okay, so I repeat, the higher rho, the lower is C. Okay, because the more you are risk averse, well, in this trade-off between losing money and being insured, you prefer to be insured. And this is why you accept a lower amount of wealth, but for sure in that case. Okay, so once again, this corresponds to the risk premium the entrepreneur is ready to pay in order to be entirely insured. Okay, but remember that in order to get this specification for the certainty equivalent, you need two assumptions. So the first assumption is that R tilde is distributed by a normal law. The second assumption is that the utility function is exponential. Okay, and if these two assumptions are satisfied, then there is one simple expression for the certainty equivalent. Otherwise, it is more complicated to find the expression of the certainty equivalent. So this is why we are considering these two assumptions. Okay, so now actually we are able to understand whether a type 2 entrepreneur is going to accept a price P, the price P, or to refuse. Because we are going to use the certainty equivalent. So in other words, this is the expected utility of a type 2 entrepreneur if he or she refuses the price P. So what we do here is just to compute the certainty equivalent of this amount. C corresponds to W0 plus the expected value, θ2, minus 1/2 times the variance of this expression. But the variance of this expression just corresponds to the variance of R tilde because the first term is a constant. So this is just sigma squared. And now what we have to compare is the utility of plus P to, is it higher than this utility? But remember that U is strictly increasing. This is a strictly increasing function. So this inequality is going to be satisfied if and only if arguments which are between brackets are strictly higher. And this is what is written here. And actually, we obtain a very simple expression, which is to compare the risk premium. This is a risk premium. To the loss of money for a type 2 entrepreneur if he or she accepts the price P. Okay, and this is basically the loss of money. Okay, because the true price is theta 2 minus P. And this is equal to what is here. So you see that this is very intuitive, because basically if the risk premium is higher than the loss of money, then you accept the price. You prefer to be insured because you are ready to pay more for being insured compared to what you are losing. Okay, so this means that this equilibrium exists when the cost of adverse selection, the left-hand side, is lower than what the entrepreneur is willing to pay to be insured, and which correspond to the risk premium. Okay, so what about now if the inequality goes in the other direction? What about if we have this? Well, in that case, type 2 entrepreneurs prefer, they refuse the price. They refuse the price P. They refuse P. Okay, so we're going to have what is called a separating equilibrium. So what is the difference between pooling equilibrium and separating equilibrium? Thank you for the answer. Thank you. What is the idea of what is called a pooling equilibrium versus a separating equilibrium? Well, in a pooling equilibrium, the two types of entrepreneur are pooled together. Everybody is willing to sell at the same price. But in a separating equilibrium, you see that there are two different behaviors. On the one hand, a type 1 entrepreneur accepts a price, whereas a type 2 entrepreneur prefer not to sell his or her firm So putting equilibrium types 1 and 2 accept the price P. Operating equilibrium only type 1 type 2 sell to the market. Okay. But this is important. Why? Because if you know, if the market know that only type 1, so I repeat. Okay, great. This is working. Okay. Consider a separating equilibrium. So type 1 entrepreneur accept to sell at the price P prime. Type 2 refuses. So what is now in this situation the equilibrium price? Well, now you see that in front of you, if you are an outside investor, you know that in front of you, you only have type 1 entrepreneurs. So the price is no longer pi 1 type theta 1 plus pi 2 theta 2. Now it is theta 1 only, because you're going to have a type 1 entrepreneur with a probability equals to 1. Okay? Okay, you agree with that? This explains this value, this new value of the equilibrium price in a separating equilibrium. Okay, so with this amount, type 1 entrepreneurs still accept this price because it corresponds to the true value of their project, and by selling in some extent their project, they are fully insured, which is what they are interested in. Okay, what about type 2 entrepreneurs? Well, they self-finance their project, because you see that if they refuse a price, so theta 1 of course is strictly lower than pi 1 theta 1 plus pi 2 theta 2. So where they refuse this price, of course they are also going to refuse that price. Okay. Okay, so but maybe we can do something better, which is going to be called signaling. That is to say, I'm not going to entirely finance my project if I am a type 2 entrepreneur, but I'm going to finance a fraction of my project. So capital I correspond to alpha I plus 1 minus alpha I. And this is going to be self-financed, and this is going to be sold on the financial market. Financial So we're going to talk about a separating equilibrium. Oh, sorry, I've got a problem with my pen. This is no longer working. I don't know why. Hey. Ah, yes. So in order to have a separating equilibrium, type 1 entrepreneurs should prefer not to mimic a type 2 entrepreneur. Not to mimic a type 2 entrepreneur. So this is going to be the case if they prefer to sell entirely their project financial rather than just a part of the project. Okay, so if they sell only part of the project, well, for this part, which is going to be sold to the financial market, the financial market is going to take them for a type 2 entrepreneur. So financial market is really to pay theta 2, not theta 1, theta 2. Okay, because in that case, a type 1 entrepreneur mimics a type 2, imitates a type 2 entrepreneur. But concerning the other part, in that case, you see that type 1 entrepreneur is going to obtain the true value. This is a true value. Okay, so this is related to a type 1 entrepreneur. And of course, what we're going to do in order to be able to get rid of the utility function is that we're going to consider the certainty equivalent. So what is the certainty equivalent in such a case? So remember, first we take the expected value. So the expected value is W0 plus 1 minus alpha times theta 2. And for the last term, it is alpha times theta 1 now, theta 1. Minus what? Minus 1 over 2 rho times variance of this expression. And what is the variance of this expression? Well, the variance, the first two terms actually disappear because they are just constant. And the second term is not a constant, it is a random variable, but alpha is a constant. So when you put alpha out of the variance, don't forget to put the square of alpha. So this is why over there you've got alpha squared times the variance of r tilde, which is still sigma squared, right? And then you obtain this expression. So the entire expression this is the sorry, there is one question, but it's kind of it's kind mysterious for me. I think it is in Vietnamese. It's not neither in English nor in French. I'm sorry. It's quite complicated for me still. I see. Okay. So let me finish with this before doing a break. Okay. So if you compare the two expressions, you see that if you compare actually this with what is over there, okay, we're going to simplify a little bit. And you end up with this expression. So this expression is just equivalent to that one. And so what is important for this is that this is a constant. And this is a function of alpha. Okay? So do you see my slides? No, you don't. Okay. Okay. So this is alpha. Alpha belongs to 0, 1. And you've got a function of alpha, which is alpha square over 1 minus alpha. So you see that you've got a function which is like this. And there is somewhere a constant. So you see that there is a range over there, an interval. So for alpha, which belongs to 1, there is separation for all this range. Because for all this range, we're going to have then the constant we are interested in. Okay, and this is basically what we wanted to understand. So I repeat. So this is equivalent to alpha being higher than alpha lower bar. Okay. So there are an infinity of separating equilibrium, and the best is of course the one which corresponds to alpha, well, alpha equals to alpha lower bar plus epsilon. Okay, so the best from the point of view of the entrepreneur, because remember that the entrepreneur, he is risk averse. It's the one with the smallest possible alpha, because it is the one for which the random part of the income is going to be the smallest. So if I show you again, yes, you want alpha to be the smallest possible, because this is the fraction of the project which is self-financed by the entrepreneur himself. Okay, and this is the signaling cost, because the remaining part is going to be paid now theta square, not theta 1, theta square. So I think it's time to make a break. So do you want to make a break? Let me know. Yes, you agree? Okay, so let's say we're gonna make a 20 minutes break and then we'll start again. Okay? See you. See you in 20 minutes. Okay, so we're going to start after the break. So usual questions. Do you see me and do you hear me? Yes? Okay, great. So let's say about this question of signaling, we actually did the complicated part of this theory. So now we're going to see the effect of a financial intermediary. So far, we did not talk about the effect of a financial intermediary, and this is what we are going to consider now. So in other words, we're going to see that thanks to the presence of a financial intermediary, the signaling cost, which is still written on this slide, is going to decrease. This is going to be the effect of of introducing a financial intermediary. So the underlying mechanism associated with signaling is still the same. But if, as we're going to see just right now, we introduce a financial intermediary, this cost of signaling is going to decrease. Okay, so here we are going to introduce a bank. And the bank is to be understood as a coalition of sharing information. So in other words, a bank knows in some extent the type of the entrepreneur, but not other investors. So in some extent, you can understand a bank as a pool of type 2 entrepreneurs. And they pull together because they are able to recognize that they have the same type, and more precisely type 2. So consider that a bank allows together n entrepreneurs of type 2. What would then be the financing condition of these entrepreneurs? And in that case, what is to be understood is a phenomenon of diversification. And so let me talk a little bit more about this. Okay. So the effect of diversification. So first, benchmark. A single entrepreneur. So the risk measured by the variance is sigma squared. Now a bank which pulls together an entrepreneur. And the risk is divided between the n entrepreneurs. And let's say that R tilde two, so the return are IID, independently and identically distributed. So in that case, you see that now for each entrepreneur, so for each entrepreneur, you have to compute the bar of and there are n times first, second, n minus 1, n. And this is times which is, of course, strictly lower than sigma square. And this is the effect of diversification. The effect of diversification is now that the risk decreases. Risk decreases. Okay. Okay, you agree with that? And cost of signaling is an increasing function of sigma. So this implies that if due to the creation of a bank, let's say sigma, oh mince. Sigma decreases due to creation of a bank. Therefore, the signaling cost decreases. Okay. So this is basically the idea of this first theory explaining the presence in the financial market of financial intermediaries. Okay. So all this point, we went to this first theory A, diversification and delegated monitoring. Okay, do you have questions so far? Other questions? No questions? Yes, I see. So about examples, we're going to do exercises. Okay. So by the way, if you want to have more details, you can also look at the Freixas and Rocher book. There are tons of exercises and other explanations about the theory. The theories justifying the existence of a financial intermediary. So, okay. Yeah, okay, let's go. Yeah. But maybe let me try something else, because you're going to tell me if it is better or not. Do you see something? Okay. Yes, this is what I want to use. So basically, this corresponds to your slides, but I think it's going to be easier for me to use this this way to show you the slides. But once again, correspond to the slide you've got, right? Okay, but precisely slide, okay? So, but the point is now, the pen is much more efficient than with the canvas, okay? Okay. So if there is a problem, do not hesitate to interrupt me, right? So the second idea is about liquidity insurance. So there are two articles, but the one which is really famous is that one by Diamond and Dybvig. And the main ideas are the following. The banks allow investors to mutually insured themselves against liquidity shocks. This allows for more efficient investment. So this is good news, but the bad news is that banks are subject to one problem, which is very well known and which is called bank runs. And I'm going to talk about that later. Okay? Is that clear for everybody? Do you see everything? Okay, thank you. Okay, great. Okay. I just want to check something. Great. Okay, it's working. Great. So what is the idea of liquidity insurance? Well, the bank, let's say that a bank as a deposit institution represents a liquidity reserve that will provide depositories with insurance against idiosyncratic shocks that affect their consumption choices. Do you know the definition of idiosyncratic shock? So it is the contrary to a macroeconomic shock. So it's not a macro shock. Okay, no, it's not this. It is a shock which is going to affect only one person, not everybody, one person. This is idiosyncratic shock. Are you familiar with that? Yes, okay, great, great, thank you. Okay. So the model is the following. There is, let's say, one generic good that is a good for everything you want to have. Car, food, everything you want to, house, whatever you want, it is this good, only one good. Each agent is endowed with one unit of good at t equals 0. So there is t 0, 1, 2, 0, 1, 2. And possibly there is a liquidity shock at t equals 1. It's not 100% sure, but the liquidity shock can happen at t equals 1, happen or not. And this is a liquidity shock which is going to affect one people, not everybody. This is not a macroeconomic shock, okay? And therefore, if someone is hit by the liquidity shock, it is going to consume at date 1, whereas if a person is not hit by the liquidity shock, is going to consume later at t equals 2. And so the utility is going to be u of c1 if the consumption occurs at t equals 1, while the utility is going to be u of c2 if the consumption is at t equals 2. So ex ante, I mean at t equals 0, the kind of the intertemporal expected utility is pi 1, because pi 1 is the probability of a liquidity shock at T equal 1. And pi 2, of course, equals 1 minus P1. And it corresponds to probability to not suffer a liquidity shock at T equal 1. And by the way, so there are two important properties of the utility function. So U is first increasing. You always prefer more than less. U is concave. And actually, this is equivalent to someone who is risk averse. So it corresponds to risk aversion. Okay, this is risk aversion. The concavity of U corresponds to the risk aversion of the agent, the person. And this is what we have here. Increasing, it is always the case. Whatever you are risk averse or risk loving. But concavity, this is really associated to risk aversion. So let's say the generic good can be stored from one period to another. But there is one investment possibility. And if at equal 0, you invest in this long-term investment opportunity, you are going to obtain at equal 2 more than initially. That is, if you invest 1, then you're going to obtain R. And if, of course, if you just store your generic good, you are going to obtain 1 by 1, not more. The problem with this long-term investment is that if you have to sell at equal 1, so this is what is going to happen if you are not hit by the liquidity shock. But if liquidity shock, then you cannot go up to time 2, and you are obliged to liquidate. Actually, you are obliged to liquidate. Liquidation at equal 1, and you obtain L, which is strictly lower than 1. So in other words, if you were 100% sure not to be injured in some extent by the liquidity shock, of course, you would always invest in the long-term investment, because you would get R, which is strictly higher than 1, and you would consume at equal 2. But you are not 100% sure of this. There is the possibility of being hit by the liquidity shock at equal 1. and being forced to consume at equal 1. In such a case, you're going to liquidate your long-term investment, but then you're going to obtain less than by just storing your amount of generic good from one period to another period. Okay? Is that clear for everybody? Cavity is a basic property that the utility of a risk averse agent person must satisfy. So if you don't like risk, the utility function which represents your preferences has to be concave. It has to be concave. Okay. Convexity is associated with risk loving. X Okay, so what is an autarky situation? Well, in an autarky situation, there is no way for an agent to exchange with somebody else by definition. So the consumption at equal 1 is going to be if with capital I, which belongs to 0, 1. So your consumption at equal 1 is going to be 1 minus I, that is the stored part of your investment, plus I times L, which is the amount which is liquidated at equal 1. And since L is strictly lower than 1, well, this is strictly lower than 1. But if you go through and consume at equal 2, then you're going to have 1 minus I, the amount which is stored, plus the return on your long-term investment. Okay, and since R is strictly higher than 1, of course, this is strictly lower than R, and the equality is only possible if and only if capital I is equal to 1. Okay? And what you're going to be is to maximize your utility taking into account these two constraints. Okay? So what about now if we create a financial market at equal 1? So now consider that people are no longer in an autarky situation, but they are able to exchange at equal 1. Okay, so for instance, just open a bond market at equal 1. Well, if you open a bond market at equal 1, that is by paying a price P, well, by paying the price P at equal 1, you are going to obtain 1 unit of good at equal 2. Okay, so I repeat, if I pay P at equal 1, well, at equal 2, I'm going to obtain 1 more unit of the generic good. So now consumption at T equal 1 is the amount which was initially stored from T equals 0 to T equal 1, plus the amount I would be able to consume at T equal 2 that I am going to sell at T equal 1 at the unit price P. Okay, and if I consider C2, well, of course, I'm going to have RI plus there is one amount of money that I've got at equal 1, and I'm going, so this amount of money is 1 minus capital I, and I'm going to buy future units of consumption. Okay, so I've got 1 minus I, the unit price is P, so the number of units I can obtain is 1 minus capital I over P. Okay? But now the question is, what is the equilibrium price? What is the equilibrium price? Well, actually, there is only one equilibrium price, possible equilibrium price, which is 1 over R. So I want to show you this. So with the financial market that's equal 1, so the equilibrium price is P equal 1 over R. So you remember C1 is equal to So there are two possibilities. So first, consider that P is strictly higher than 1 over R. What would you do in this situation? Well, then it is optimal to invest entirely at t equals 0. Because if there is a liquidity shock, you would get PR, which is strictly than 1, what you could have obtained by storing everything from t equals 0 to t equals 1. But actually, this is not an equilibrium, because everybody would do that and there would be no exchange at t equals 1, because no one would still be able to buy something at t equals 1. So this is not possible. The other possibility is be strictly lower than this amount. Okay, which is equivalent to if this is the case, it is optimal not to invest at all in the long-term investment. Equals 0. But then there is nothing to buy at t equals 1. Okay, so there are no exchanges whatsoever. So this is not a possible equilibrium either. So the only remaining possibility is that one. But in that case, you see that with C equals to 1 over R, C1, which is equal to plus PRI, well, this is equal to 1, and C2 is equal to so what we can say is that the situation with a financial market dominates the autarky situation. because in that case you have but it's impossible to have the equality for the two. But if C1 equal 1, then C2 strictly lower than R, and if C2 equals R, then C1 is strictly lower than 1. So the situation with a financial market dominates the situation without a financial market, the autarky situation. So I belongs to the interval 0, 1. So remember, so if you remember, so I would like to answer one question about capital I. So initially, you've got 1 unit of the generic good. Let's say money. It is, for instance, money. This is money. So I is the level, the investment in the long-term investment possibility. So you invest part of your wealth, that is capital I belongs to 0, 1. Okay? Okay, so this situation, the market equilibrium situation, Pareto dominates the autarky. So what would be the optimal allocation? So of course you want to maximize with respect to capital I your utility, and because this is consumption that you're going to have later, no, nothing, sorry. So subject to what is the constraint which has to be fulfilled? Well, it is that your consumption should be lower than what you have to invest, right? Your expected consumption has to be lower than what you have. But actually here you divide by R. Why? Because if you want to consume, so if you want to consume a quantity C2 at T equal to, well, you have to invest an amount C2 over R at T equals 0. Because 0, 1, 2, if there you have C2 divided by R, there you're going to have C2 divided by R times R, which is going to give you C2. Okay, so this is the maximization program we want to solve. And because you don't want to waste consumption, then you put equality over there. The constraint is binding. Okay. Well, then it is quite simple because you can use the constraints to express everything in terms of C1 or C2. Sorry, here it's not capital I. It is C1, C2. But if I use this constraint, so by using 1, then and you have to maximize C1 of C2, so this is basically what you are interested in. So if you compute a first order condition with respect to C2, you obtain or and actually That is what you have sorry, there is also this expression, sorry. So this equality allows us to characterize the optimal choice of consumption by an individual. Okay. So this corresponds to this relation indicates what the optimal amounts of consumption are. No, sorry. Yeah. Where is it? Yes, over there. Okay, great. And let me, okay. So this is precisely what we were just talking about, this condition. So you remember that in the market equilibrium, we obtain C1 equals to 1 and C2 equals to R. So except this very particular case in which we would have this relationship, the market allocation is not actually optimal. Okay? So except in this very particular case in which this is satisfied, so except if this is satisfied, else the market equilibrium is not optimal. So now the question is it possible to obtain the optimal allocation thanks to the introduction of a bank? Well, actually, the answer is yes. And why is it the case? Because liquidity shocks are idiosyncratic. It's not a macroeconomic shock. So this corresponds to the amount which is going to be stored by the bank at t equal 1 and which is going to be repaid at t, which is going to be stored at t equal 0, by the bank from t equal 0 to t equal 1. And the other amount is going to be invested in the long term by the bank. And actually, you see that now, if you consider a mass of individual, pi 1 is no longer the probability of facing the liquidity shock. It corresponds to the proportion. This is now the proportion of individuals, which the proportion of people which is going to suffer from the liquidity shock. So there is one important result, which is to say that in an economy in which each agent faces liquidity shocks which are independent, so idiosyncratic, introducing a bank allows to reach the optimal allocation. Okay. Of course, this would be totally different if the liquidity shock was actually not idiosyncratic, but a microeconomic shock. Okay, this would change totally the result. So for those of you who are familiar with the economic theory, you should be surprised by this result. Why? Because we know, due to the welfare theorem, that when the market is perfectly competitive, as it is in our case, we obtain the optimal allocation by using just the market, a perfectly competitive market. So the question is, why the market economy fails to provide an optimal allocation? Actually, this is the case because financial markets are incomplete. This is due to the incompleteness of financial market. Okay. Why do we talk about incomplete financial markets? Because actually there is no forward market in our case. That is, there is only one financial market at t equal 1, but not a forward market at t equal 0 through which you can hedge, you can cover yourself about the future liquidity shock at t equal 1. And why is it the case? This is the case because actually the situation of each agent is not necessarily observable by everyone. So it is impossible to create a forward market. So in which contracts would be signed at t equal 0 and executed at t equal 1 for those who would suffer the liquidity shock at t equal 1 only. Okay, so markets in our case are incomplete, and this is why the market economy fails to replicate the optimal allocation. But a bank is able to do that by using the law of large number, because for a bank, this is no longer, this is something which is sure. So the bank knows for sure that at equal 1, this is the amount that is going to be repaid, not more, not less. And the rest is going to be investing in the long-term investment possibility. And it is going to be repaid at equal 2. And what is important is that this is going to respect this inequality by definition of the optimal allocation, that one. That one. Do you have questions so far? Okay, good question. Yes, because in this case, it is the only market is missing. So today, I'm not going to talk about robustness of banks. I'm going to talk only about that if I have time. Else, I'm not going to talk about that. So let me just say a few words about bank runs, because this is something which is crucial. And this is a well-known danger for a banking sector. So you see that there is one principle, which is the rule of first come, first served. So in other words, the sequential service of deposits can lead to bank runs. So in other words, the bank can fulfill its promise, C1 star, C2 star, because exactly this proportion of depositors withdraw at equal 1. And we know that P1, C1 star plus P2, C2 stars over R is equal 1 by definition of an optimal allocation C1 star, C2 stars. The problem is that if more people goes to withdraw at equal 1, then the bank is no longer able to serve people, and there is a bank run, and then bank run. Okay, so this one is one equilibrium, one possible equilibrium, but actually there is another one, which is a danger for the banking system. So let me give you the idea, and then we're going to stop up to tomorrow. So consider that C1 is bigger than 1. And suppose that all investors but one withdraw at equal 1. So everybody except one person withdraw at equal 1. What would be the optimal reaction for that person? To go to wait up to t equal 2, or also to withdraw money? Well, actually, if this is the case, you see that the bank is going to, if all investors but one withdraw at equal 1, the bank is obliged to liquidate all long-term investment at t equal 1. Because even this is lower than C1. So remember that capital L is lower than 1. And therefore, you see that the last investor, if this last investor waits up to t equal 2, it will end up with nothing. And therefore, he or she is better off withdrawing at t equal 1, that is running what is called running with the others. Okay, and this is a real danger for the banking system. And let me just conclude with this last slide, which is one example of a bank run. You see people waiting over there, queuing to withdraw money. So this was in 2007. The first bank run in England since 1866. Okay. So I think it's time to stop, but I've got some question, I think. So that means if we have forward market, equilibrium could be optimal, no need for a bank. So the answer is more complicated. Why? Because here it's not the question of opening a market, a forward market, to complete the financial market. Why? Because this market is not viable. Okay, this is why this market doesn't exist actually. So let me show you this. Financial markets are incomplete, but they are incomplete because you don't observe the situation of each agent. You don't observe the situation of each agent. So if you open a contingent market, everybody is going to cheat on you. And this market is not viable. So this is why actually this market is not open. Okay, so this is for the first question. Autarky. So what about the autarky? Yes, over there. Okay. So in the autarky, we've got C1. Yes, in the autarky. C1 is equal to what you store from one period to another period. And then you've got your long-term investment. But you are obliged to liquidate your long-term investment. And in that case, you don't obtain, you obtain less than 1, and it is called L. And I agree that in order to have C1 equal 1 in the autarky situation, we must choose I equal 1. Yes, I agree with that. So 1 minus, yes, in some extent, 1 minus I, it corresponds to what is stored by the agent. That is not invested in the long-term investment, financial investment. Okay, we are running out of time, so we're going to stop now. Do you have questions? Other questions before tomorrow? No, no questions. So let me ask you a question. Do you want me to send you the what I wrote on the PPT on the, let's say, whiteboard? Yes, you want? Okay, yes, highly appreciated. Okay, let's do that. Okay, so see you tomorrow, and enjoy your evening. See you tomorrow. Goodbye. Bye bye.